first introduction to the characteristics of quadratics. And this is the formula that you need to memorize. I want you to know that quadratics are a parabola. It's a U. And there's certain characteristics of this parabola that I want you to recognize. The acronym that I created for it was Dr. Divaxi. That just helps you to know what it looks like. Okay, the parts of it. Here we go. So this parabola, first of all, let's just do some basics. Whatever number is here, so let me just make up some numbers. So you need to know which number is A, which number is B, and which number is C. So that's kind of the basic. So in this particular problem, what's A? 2. What's B? 3. And what's C? Okay, so one of the easiest parts of this, and it's going to skip around so there's really no order. The easiest part of this is this one right here, which is C. Whatever number here is your C, this is your y-intercept. It's where it crosses the y, so it's this part of Dr. Divaxi. It's kind of the easiest one. Okay, let's do, I guess we'll do the D. Okay, the D part of this stands for domain. All right, so let's look at this graph right here that I just drew. This one in particular is called the parent function. This one looks like y equals x squared. And then there's all these different parts to this that it changes that will change the look of this graph. All right. So here's my x-axis, here's my y. If we were all standing here on this function and we ran to the x-axis, how much of that x-axis is covered? The whole thing, right? So the domain here is going to be all real numbers. The R is range. And again, in this particular problem, if you look at the range, we're now standing here on this function. We all run to the y-axis. How much of that y-axis is covered? Not the whole thing. Good, 0 up. So y is greater than or equal to 0. Good. Okay, D, the second D. This is going to get complicated, so I really want you to listen to this. This is what the kids have the hardest time with, but it will be way easier for you if you can understand it in Algebra 1, because you're going to see it again in Algebra 2. Let's pretend I'm standing over here, and you kind of have to ignore these arrows. The arrows mean it just goes up and down. But if I'm going from left to right, this function is decreasing. So what I mean by decreasing, let's say this x value is -10. As I move along, that means this number might be like -5 right here. This one's -4, this one's -3, -2, -1. Do you see how these x numbers are all negative? So from here to here, it is decreasing. And here's how you're going to write this. It's going to be kind of weird. When x, so this is called my vertex. We'll talk about that in a second. This vertex. So from here to here, this function is decreasing when x is less than 0. So here's my vertex. From here down, when x is less than 0, it's decreasing. Now let's go from this way. That means from the vertex up here, what's it doing? Increasing, good. Now again, we'll just do a lot of practice for this. So it starts to increase where? At 0, good. So anytime that x is greater than 0, it's increasing. And I'm going to show you a bunch of different graphs so that you're used to it. So that's the D and that's the I. V is the vertex. Look at this one here. The vertex is the very bottom or the very top. Where is the vertex here? 0, 0. Okay. Axis of symmetry. That's the A. Axis of symmetry. I call it AOS. Capital A, lowercase o-s. Okay. The axis of symmetry is always an equation. So know that. It's always an equation. And it's always x equals in this particular one. So I'm going to do this in purple. Take a look at this function. If I were to fold it in half, where would I fold it in half so both sides match? At 0, right? So look at this line, my purple line. That is the very middle, and that's 0. So that means that my axis of symmetry is x equals 0. Now, mind you, we're looking at the parent function. That's why. So that's A. Okay, x. X is the x-intercepts. Where's the only place that this thing is touching the x? 0. Now, again, y is the y-intercept, and not this equation, this was just my example, but in this graph right here, where is it crossing the y? Also at 0, because it's the parent function. Now, if you can remember all of those components, you're golden. That's why I came up with the word Dr. Divaxi. I actually used to call it Dr. Vaxi, but then I want to include decreasing and increasing, so period 4 I thought of Dr. Divaxi. And then you guys can do number 1 on your own. So, what do you want to start with on number 2?
Vertex.
Vertex, very good. So, looking here at the vertex, that's the V part. What is the vertex of this function? Negative 3, 7. Very good. Okay. What else would you like to start with? Axis of symmetry, yeah, the axis of symmetry goes along with the vertex, and it's where you're going to fold it. So I'm going to draw this here. It is always an equation. So x equals negative 3. Do you notice that it is the x part of my vertex?
Yep.
Okay, so it's x part. Now, if I do my x and y intercepts, they're not very clear here. So there's one here and there's one here. And for this particular problem, we'll just guess. We'll guess to mean. So this x-axis, this intercept is about what? Negative. Like, let's say it's negative. Let's say it's negative 5.5. So 3, 4, 5.5. Right. So this one would be about what? Negative 0.5. Let's just make it negative 0.5. Good. Now, do you see the y-intercept? Here's my y, and it's crossing down here somewhere. It's not quite crossing at negative 1, but it's probably going to cross right after that. So let's just say that our y-intercept is negative, let's say 1.5. All right. Domain and range. What's my domain here? All real numbers. Okay, range. Range is y is less than or equal to, very good, 7. Awesome.
Wait, so the axis of symmetry is always going to be like the x of the vertex?
And the range is always going to be the y. And it's either going to be greater than or less than. Absolutely. Okay, the last two, decreasing and increasing. So I'm going to draw these so they're a little bit easier for you to see. So let's say we're starting here from left to right. Oh, let's just start somewhere here. So it's going to be x something. And it's going to be, which one did I tell you? The axis of symmetry. So x something negative 3, x something negative 3. Okay, let's look here. As I am going from left to right, so I'm going here. This graph is actually increasing. Good. So when x is what, is the graph increasing? When x is, well, here's -3. All these numbers right here. When x is less than -3. Because it's everything less than. Okay, so this is increasing. Now, as you reach -3 and my x numbers get larger, because they're getting larger here, what's happening to my function? It's decreasing. So it's decreasing when x is greater than -3.
Wait, how do you find
Very good. Looking into the parent function, and we're going to compare everything to the parent function, which is y equals x squared. And the points we did here on the side, that's what the points should look like. So the first case we're going to look at is when a is greater than 0. What kind of number is it when a is greater than 0? It's positive. All right, this is your biggest clue. When a is positive, it is always facing up. Always. So that means, and I'm going to draw a second graph here. Pretend that's touching up here, sorry. This case is when a is less than 0. When it's negative, it will always be facing down. Those are your first two clues. Okay, next part of this. The next part of this is when a is a fraction, when it's between 0 and 1. When a is between 0 and 1, which means it's a fraction, it's going to do this. It's going to flatten out, and when something flattens out, it's called a shrink. So now the next case is when it's not between 0 and 1, it's not a fraction, it's when a is greater than 1. When a is greater than 1, it's going to look like this. It's as if it's stretching up towards the sky. And that's why it's called a stretch. Okay, now going down to the negatives here. I'll start with the shrink. Again, when a is between -1 and 0. So remember, it's negative, which means this is a fraction. It's going to look something like this, which is considered a shrink. Okay, so that means when a is less than -1, it's going to be considered a stretch, and it's as if it's stretching downward.